Okay. Yeah. Hi. Good afternoon, everyone. And welcome to our IP to Profit webinar series, which is co-organized by Pintas IP Group, IP Tech, and also GIP ASEAN. Today, we are going to explore on one of the most compelling story in modern innovation, which is the rise of Dyson and how the strategic use of intellectual property by Dyson transformed Dyson into a global technology powerhouse. So thank you for those who join us today. Welcome and thank you for your attendance. Okay, I think I would like to just briefly introduce myself. My name is Lok. I'm from Pintas. I'm a patent attorney with Pintas IP Group. I'm a qualified patent lawyer for both Singapore and Malaysia, and also a registered patent and trademark and design agent. For the past 20 years, I have dedicated my work to the building of IP ecosystem. I do consulting work, filing protection work, and also strategizing work of IP portfolios for clients across ASEAN countries and China. It is my pleasure to share with you today how Dyson cleverly used IP to build a world-leading technological empire. Okay, so this presentation will share the remarkable story of how Sir James Dyson creatively disrupted the home appliances industry. We will examine how IP plays a central role in Dyson's journey from a garage inventor to become a global engineering icon. Okay, Dyson was founded in 1991 in England. From its very humble beginnings, it grew into a global household appliances leader. In 2019, Dyson made a strategic move of relocating its headquarters to Singapore, bringing R&D, engineering, manufacturing closer to the key global markets. This move accelerated the company's growth trajectory. Okay, and first we would like to explore what is the business strategy of Dyson. And to do that, let us look at the Porter generic competitive strategy framework. In the Porter generic strategy framework, Professor Michael Porter, says that there are three basic strategic options open to companies. Either you focus on cost leadership, or you choose to be a differentiator and you choose your focus market. And according to Professor Porter, a company that do not or fail to develop its business strategy in either these three directions, a firm that is trying to be everything to everyone will be a firm stuck in the middle. And that kind of company will be in an extremely poor strategic position. So you have to choose. Either you want to sell to be a cost leader or differentiator. And for the case of Dyson, right? Dyson very firmly positioned itself in the differentiation strategy. It strives to create unique high-performance products that command premium pricing. Right, so we all know that when we buy Dyson, we go for the premium, high price, quality, high quality and efficient product. And what is interesting is Dyson differentiates itself by building better machine, by not putting more things into the machine. It makes better machines by taking things away, right? So if you see the vacuum cleaner, Dyson moved away the bags from the traditional vacuum cleaners. It moved paper towel away from the hand blower, and they moved blades away from the conventional traditional fan. And with every subtraction, they added performance, they added efficiency, they apply a law of physics to make it better and more efficient. And also they add in the design brilliance and leading to a globally competitive and also premium price product. And that is, in essence, the Dyson competitive strategy. And the Dyson uses intellectual property to create an IP moat for its company. And this concept of IP moat was developed and popularized by Warren Buffett. Warren Buffett will only invest in company that has strong economic moat, right? Companies with strong economic moat would be able to achieve sustainable competitive advantage, meaning they can make profit for foreseeable future. The competitive advantage will not be competed away by competitors. So the Dyson's economic moat are built mainly from intangible assets, from intellectual properties, from the patents, from the trademarks, from the design, from the proprietary technology. Today, we are going to explore all this, right, together in this 1-hour webinar series. And for Dyson, intellectual property power its innovation engine. Dyson uses patent to protect its innovative functions, uses trademark to protect its brand identity, and also design to protect its unique appearances. Together, intellectual property safeguard Dyson's ability to innovate freely and also to dominate commercially. And intellectual property is a very important engine of growth for Dyson. Okay, before we dive into Dyson case study, I would like to revisit some of the basic of IP, right? For those of you who are new to IP, I would like to just very briefly talk about different types of IP. First, I would like to talk about patent. Patent protects new invention. The new invention can be a machine, it can be a process, it can be a composition of matter. And then you have copyrights that protects your content, your original expression, your creative work. And you have trademarks that protects your brand, your identity, and your promises to the consumer, right? And you also have industrial design that protects the external appearances of your end products, and trade secrets that protects your know-how that give you an edge. So in essence, intellectual property transform ideas, a very fluid, novel idea. You have a very bright idea and it's very fluid. Through intellectual property, you transform it into a legal assets. Yeah, so that the transformation, you have to go through a registration process, protection process, and with that legal assets, your company has a monopoly, which is the right to use, to make, to sell something, and this right is limited with jurisdiction, by jurisdiction, and also limited by time frame, right? These are the common characteristics of intellectual properties. Dyson mastered this IP playbook very well, right? If you look at the evolution of Dyson, all new products introduced by Dyson were all well protected by IPs. Without intellectual property, all this innovation will just slip away. It will become, public domain knowledge everybody can use. But with intellectual property protection, innovation become a very valuable assets to the company, and also a very important moat for the business, economic moat for the business. Okay, and this is a chart that I would like to share to say that, how the value have moved over the 5 decades, right? If you look at the chart produced by Ocean Tomo, it shows that in 1975, only 17% of the S&P 500 companies value came from intangible assets, right? Intangible assets are things like your patents, your trademark, your copyright, your design, your data. And tangible assets are factories, machinery, physical inventory. And fast forward to today, right? In 2020, the world has completely flipped. By 2020, intangible asset make up of 90% of the total corporate value. That means that every $9 out of every $10 of value comes from intangible assets, comes from your innovations, come from your intellectual properties, your technology, and not from the physical assets. So companies that invest in building, in protecting, and also in monetizing those intangible assets are the ones that are able to scale faster. They can grow faster. They can compete globally and stay resilient. And this is the value landscape of today. And that's where the tomorrow's winner will be built, right? So that's the importance of intellectual properties rights. And what are the basic functions of IP rights? The slide shows that there are two basic functions of IP right. First, IP creates a legal barrier to entry, right? So when you have a good innovative idea with IP protection, you prevent competitor from copying your innovation and giving you a protected space to grow your business and to put in more investment, right? So people cannot just simply copy. So it gives you space to grow your market share and also to protect your investment. And secondly, IP provide freedom to operate. So it means that with this freedom to operate, your competitor will not be blocked, will not be challenged because you are infringing someone else's IP, right? So IP serve two functions. First, it protects your innovation from being copied, from being imitated, and it protects your business from risk, right? When you have IP, people cannot sue you for infringement. So it is a risk protection tools also. So it keeps competitors out and it allows you to move your business forward. So these are the values of intellectual properties. Next, I would like to go into the patent, right? I'm going to share some of the patent filed by Dyson. Okay, and I would like to introduce this concept of patent for those of you who have not filed patent. When you look at patent and we break it down to its most basic form, in essence, patent is a game of combination. It is on how you combine existing parts into a new way that solve a problem. And this new combination, if it's new and if it's deliver better technical result, then it is qualified to be protected as patent. So the biggest breakthrough in human civilization often come through from combining, right, what is already existing in something new. And that something, the new combination deliver a better result and or solve an industrial problem. And let's look at some of the example, right? The 3M post-it tag, it can be Xerox photocopying machine, it can be Tetra Pak vacuum packaging process, it can be Pfizer's drugs, right? Whether it's an article of manufacture, whether it's a machine, whether it's a process, whether it's a composition, the magic is not inventing from scratch. It is about recombining things in new way. You look at 3M, you combine paper and glue. Paper has been around, glue has been around. When you put them together into a single product, it deliver a lot of value for the office user, and it was a very successful product. The Post-it, very successful product for the 3M. Or you talk about photocopying machine, the engineers at Xerox put the roller, the photo camera, the motor together in a new machine. Then it solved the problem of photocopying documents and it become a hit again, right? So these are examples of patent. And today we are going to look at how Dyson combine existing parts into something new and using the law of physics to solve problems and own that solution in the form of patents. Okay, so yeah, to be patentable, right, there are three criteria, right? The first criteria is the invention, the combination must be new, novel. Secondly, is the combination must be inventive, meaning deliver a better result. Thirdly, the combination must work, right? Useful, meaning it can work, right? It's not just a concept that cannot work, it must work. So these are the three simple criteria to get a patent. And if you can meet these three criteria, you have a patentable proposition. So I'm going to start by looking at some numbers behind Dyson's patent portfolio. All in all, Dyson hold more than 15,000 patents globally, out of which 5,000 plus are granted patent and another 4,000 plus are pending patent, right? These are the total number of patent filed by Dyson. And let's look at some of the filing trend by Dyson. Dyson has filed patent consistently over the years, but certain years there were spikes in the filing numbers, and those spikes coincide with major product launches. Like for example, when they launched the bladeless fan, the hand dryer, the hair dryer, the numbers come up a bit, right? So these are the trend, the filing trend of Dyson's patent. Next will be the filing technology domain claimed by Dyson, right? Dyson filed the most patents in the electronics, in the household appliances, household goods, consumer goods, and also the furniture categories. Yeah. So when you file patent will be categorized into certain classification number, right? Though these are the key classification where Dyson's file its patent. Next will be the country of filing. As I mentioned just now, right? Patent is a jurisdictional right. It's limited by country. So when you want your patent to be protected in more than one country, then you have to file in different country. So when Dyson filed its patent, it looks at its key market, and its key markets are places like China, UK. Being a UK-based company, they filed a lot in UK, in US, in South Korea, Europe, and Japan. These are the geographical distribution of Dyson's patent. Next, I would like to share with you the patent map of Dyson, right? We can see that Dyson uses patent as a strategic weapon. So no parts of their product is left unprotected, right? Before they launch anything new, they will file patents for all the key improvement or the key invention inside the new products. So that's the reason why, right? When we look at the patent map, we find that Dyson holds more than 100 registered patent across every product category that they operate in. So from the Dyson patent map, we can see a visual proof that their competitive advantage doesn't come from one single big idea, but from protecting a dozen of small innovation. They patents the motor, they patents the airflow, they patents the filtration, the sensor, and so on and so forth. So with those protection, right, with strong protection, then you build a defensible long-term economic moat, a long-term market advantage for the product. And people wants to come in, they are faced not with one patent, but a portfolio of patent. This is also called, in the patent terms, a fencing strategy, right? It fences its products with a portfolio of patents, and the key innovations are being protected. Yeah, this is the patent map of Dyson. Okay, and I have summarized, we have summarized some five of the key patents behind five iconic Dyson's product, which we are going to talk about today. But if you are interested, you can scan and take a look, and probably can learn a bit more from reading the full patent itself, right? But today we are going to do an introduction of those five key patents. Okay, okay, well, I would like to start with the first most disruption, the earliest disruption by Dyson, which is the cyclonic vacuum cleaner by Dyson. So in 1978, right, Dyson first realized the problem with the conventional back vacuum cleaner. And it sets out to find a better way to do vacuum cleaning. And this led him to develop the world first backless vacuum cleaner using cyclone technology. Cyclone technology is an idea inspired by the industrial cyclone tower. So Dyson see that being used in the industrial tower using the cyclonic power to separate the husk from some agricultural produce and he turned that into. So it was not a short journey. It took him 15 years and 5,000 experiments for him to come up with this first dual cyclone vacuum cleaner, right? So if you look at the traditional uh, vacuum cleaner, right, it's not with this traditional vacuum cleaner using back has not been very satisfactory, right? Because the conventional back vacuum cleaner does not produce enough suction power to remove dust properly, especially after some time, the back get clogged and then the suction power fall, right? That's the pain point. The traditional vacuum cleaner using back as the filter is not totally satisfactory. And Dyson realized that the reduction in the suction power is not due to the volume of the dust in the bag, but it is due to the fine dust which is clogging the pores of the bag, right? So when it is clogged by the dust, the suction powers falls dramatically, right? So there's also the problems of fitting the bag and dislodging the bag. Every time you have to clear the bag and the bag get torn easily, right? So this is not a good solution. There must be a better way of doing vacuum cleaning. So Dyson developed a radical alternative, throw away the bag, find something better, right? This is the solution found. So what's the physics behind the invention, right? If you look at Dyson's invention, they all have the basic solution is using law of physics to solve a problem and then put it into a machine. And the law of physics behind this invention is, if you look at the tornado, you can see its very astonishing power in the twisting air. You can suck everything up, right? And the dual cyclone follow the same principle, but on a much smaller scale, using motor, the air, the dirt-laden air is sucked into the vacuum cleaner. Okay, and this is the working principle behind the dual cyclone vacuum cleaner, where Dyson uses a motor to produce an airflow, and the dirty air is sucked into the vacuum cleaner, and as it enters the vacuum cleaner, it starts to spin in a cyclone, right? And then because dust is heavier than air, right? So the central petal force within the cyclone will throw the dust to outside the bin, right? So it separates the dust, and the airflow will move through the bins. Yeah, I can point. The airflow will move through the bins, and it will go through a perforated skirt with a filter, and the heavier dust like the hair, the flaps will be removed, and then the air move into inside. This is the first cyclone. The heavier dust will be separated through centripetal force, and it move inside the second inner cyclone where smaller dust will be removed. This is how it works. And Dyson patented this basic invention, the dual cyclone system, in this patent, this first patent, which was originally found in Europe way back in 19, let me see, way back in 1981. That was more than 20 years ago. The patent has expired since, but this is the first patent filed by Dyson. And I mentioned that patent is a combination game. So what are the combination protected by this patent? It protects a combination of a cyclone unit of successive higher efficiency, meaning you have two or more cyclone unit. The second one is higher, faster than the first one. And the higher cyclone have a Fusco conical shape, taper away from the entry. So this this conical unit in the faster unit basically this is to speed up, right? This cone unit is to speed up the airflow, and then you have a mean of generating the airflow, which is the motor, and also the lower efficiency of the cyclone unit has a cylinder. Yeah, this is a cylinder. So it's a combination of two cyclone or more. The second one has a cone. The first one has a cylinder and a motor to suck in the air. And the combination of A, B, C, D is the essence of what Dyson owned through this patent. So anyone copy A, B, C, D will be infringing Dyson's patent. That's how it works, right? And Dyson tried to license this patent to major manufacturer, and it was turned away. The reason is simple, right? Those major vacuum cleaner manufacturer, they have invested a lot in the vacuum bags, and then they don't want to cannibalize their own business. So new technology that disrupt their own business, they won't be interested. So it show one thing: it's very hard for new revolutionary technology to find adopters at the early stage. That is the reason. You have to disrupt a lot of things, so people may not welcome your entry. So eventually found a willing licensee in Japan, and with the royalty collected, they started the DC01, which is the world first backless vacuum cleaner. So this is the vacuum cleaner that incorporate the dual cyclone, and it is efficient. It doesn't lose suction power. And what happened was, this product managed to capture a lot of market share, and market share in UK grew from 50 to 50%. When this new product was introduced, and there was another producer, Hoover, another big American multinational, the market share declined from 25% to 10%. So what happened is Dyson managed to dominate their market share for vacuum cleaner, and the other incumbent big players, Hoover, response was to copy his clone technology, and bet wrongly that because Hoover was big and Dyson was small at the time, Dyson wouldn't dare, to sue, wouldn't dare to take action against a giant. And it was proven wrong. This was a defining moment for Dyson. Dyson took action, used the patent to sue Hoover in court. And Hoover alternative is called a triple vortex. Instead of using two cyclone, Hoover thought, I add another cyclone, so mine is different, so I can sell in the product. This is the thinking of Hoover. So when you go to court, right, what happened in all the cases that we do is we have to prepare a comparison table. We have to put the claims on one column and the products in another column, and we want to see whether the products has all the element claimed in the patent or not. So in this particular case, a side-by-side comparison was done. So the triple vortex is a vacuum cleaner. Triple vortex uses cyclone, 3 cyclone versus 2 cyclone, but yet they are all cyclonic unit of higher efficiency. So they tick the box. And the next one is they have a tapering conical unit, which is also found in the triple vortex. And they also have a motor that generates the airflow. And also they have a cylinder to collect the dust. So all elements are found to be present in the patent, claim in the patent are found in the product, and it was found to be infringing. So triple vortex was found to be infringing all the claims, right? In patents, you have multiple claims, and every claim you claim addition, different combination. So all the claims are being infringed. So the court decided that, right? The High Court of UK decided in favor of Dyson in October 2000, and Hoover was ordered to pay £4 million in damages, and there was additional orders from the court blocking Hoover from reintroducing the product for another year after Dyson's patent expired, right? So this is a significant victory for Dyson. It validated Dyson's patent, and it reinforced the power of a strong IP, right? So this is when your patent is tested in court, it is validated and it strengthened the value of the patent. So after winning this vacuum cleaner battle against Hoover, Dyson managed to consolidate the market. It managed to establish itself as a premium vacuum cleaner brand in the consumer market. So as a patented product, you can sell higher. So you look at the price range, right? Hoover's price is almost double that of Hoover and other brand, right? So this is called a moat, economic moat, where you can charge higher premium, and yet people cannot copy you, right? So what is remarkable in Dyson's case is Dyson didn't rest on its laurel, right? It has scored a major victory. It didn't stop there. Once they master the cyclonic separation technology using the centripetal force, they expanded the engineering foundation into a new entire ecosystem of breakthrough products, from cordless stick vacuum cleaner to hand dryer to bladeless fan to hair dryer and also to hair styler. So I'm going to go through all this innovation with you and see how Dyson protected those innovations. The next chapter in Dyson's evolution for vacuum cleaner is the stick vacuum cleaner. I believe many of you has this at home. Me too. This stick vacuum cleaner is the next generation of vacuum cleaner from Dyson. Dyson realized that modern consumer value convenience just as much as the raw power, the suction power, right? Traditional vacuum cleaner were bulky, wired, difficult to maneuver. So Dyson took this cyclonic technology, which is originally designed for upright heavy machine, and miniaturize it, and without losing the performance, and put it into the stick form. So what they did is they have to re-engineer the airflow, re-engineer the geometry of the cyclone, and they have to develop a smaller and more powerful motor. So all they do together, and the result of that is a lightweight stick vacuum cleaner with outstanding suction power, and this is created consolidate Dyson's position in the vacuum cleaning market. So this stick vacuum cleaner is protected by this patent filed in 2019 or filed in 2016. And since that has spreaded, right, it has become the new favorite vacuum cleaner worldwide. So this Dyson stick vacuum cleaner covers a handheld vacuum cleaner with an inlet duct, right? They have an inlet duct which is parallel to the cyclone chamber, and you have the cyclonic separating unit, right? You have you have the first cyclone and the second cyclone. You have the second cyclone separating unit wrapping around the inlet ducts, right? So this arrangement, the parallel alignment, is not only aesthetical. This arrangement can reduce turbulence. It improves the dust separation efficiency, and you allow Dyson to shrink the size and to improve handling of the vacuum cleaning, right? So let's look at the patent, the claims of this patent. What it protects, right, is a combination again of parts. It has a handle to hold, and you have a primary and secondary cyclone separator. You have an inlet duct to suck in the dirty air, and you have the secondary cyclone that wrap around the inlet ducts, right? So this wrapping around allow Dysons to pack high efficient cyclone separation unit into a very compact device. So this is a next step, right? Initially you have two, but now you have got multiple smaller separation unit wrapped around the inlet to do the second separation. So this combination is the foundation of this stick vacuum cleaner, right? So if you're interested, you can take a look at the handbook, yeah, which you can download. And also Dyson, as Dyson expanded into the stick vacuum cleaner, they realized that, okay, how do we store this stick vacuum cleaner? Storage, ease of use, they are the key customer pain point. So they come up with this concept of the wall mounting docketing system that do charging, right? You can hold the stick and you can do charging. It keeps the vacuum uptight when you store it. You charge the vacuum and it is ready to use every time you want to use it. So it's another clever idea, which is patented by this patent, right? This bracket wall mounting docking system station, yeah, wall mounting docking station. So again, what combination is protected, right, by this patent? Again, a combination of part, right? This docking system protects a mountable docking system with opposite pair of clamp. You have the clamp that clamps things together, and the clamp has a resilient spring that couple to one of the clamping members to hold the vacuum cleaner, and one clamping members involve sliding motion, and other clamping members involve pivoting movement. So again, this combination of having a wall mount with these clamping members and one in charge of holding, one in charge of pivoting, one in charge of sliding is the patent covering or protecting this wall mounting station. Any competitors who wants a similar mounting will be risking infringement of this patent, right? So this is another example. So next, I want to move to another Dyson disruption, the air blades hand dryer, right? If you conventional restroom used to use two options, either you use paper towel or you use the warm hair dryer, and both are not eco-friendly, both are not efficient. So Dyson approached this problem, right, from a fluid mechanics perspective, not from a heating perspective. So the mindset, right, led to the air blade, right? This is the famous air blade, which is a trademark, right? Air blade is a trademark owned by Dyson, using high velocity sheets of air to wipe water off your hand in seconds. Doesn't use heat, doesn't use paper towel. And this is a radical reinvention of a decade-old technology, an old concept of how you dry your hand. And this air blades is protected by this patent, right? You can take a look, and it combines HEPA filter that filters, make sure clean hair touches your hand. Air jets, right? You can use kinetic energy instead of heat energy to move water from your hand, and then you have ultra efficient motor that allows for a compact design. And this patent filed in 2006 protect this hand dryer. So what is the combination protected by this air blade hand dryer? Again, it's a combination of you read the claims, right? It's using the thermoplastic wall that can withstand thermoplastic wall. You have the upstanding slot member to put in your hand. You have fan that generates the airflow. and you have dual opposite slot line opening, which control airflow in two directions so that the airflow touches both sides of your hand simultaneously, right? This is the combination. Translated to patent language, this is the claim that you get, right? So in essence, it means the combination of all these four put together into a hair blower air blades hand dryer machine. Okay. Next, this is a very iconic product from Dyson, bladeless fan. Dyson does not just improve fan, they remove the very components that everybody assumed was essential. Yeah, the blades, everybody talks about fan, it talks about blade, right? Traditional fan creates turbulent airflow and it requires protective cages to protect people from touching those blades. And then Dyson approached the problem not as a fan engineer, but from the angle of fluid dynamics again. They're using the aerodynamic law of inducement and entrainment, right? They produce a uninterrupted flow of air. And this bladeless fan introduced in 2008 become another Dyson most iconic invention. So this is a law of inducement and entrainment. I believe many of you can check. Basically, what it shows is inducement by when you create inducement, pull the surrounding air into the flow, and then entrenchment drag the additional air along the main air pathway. So this is the physics behind this bladeless fan. And this amplification process effect of inputting a small input of air into a powerful output of air is called air multiplier technology. And this air multiplier technology is protected by this patent. Yeah, the airflow become 15 times stronger than the original intake. And this physics, right, is all based on the law of entrenchment and the law of inducement. And by designing, the outlet to be shaped in an aerodynamic design, this can be created. Okay, so how is this bladeless fan protected? Again, you can look at the claim, and this the bladeless fan is protected by this patent, right? Which was filed in 2009, and it is a combination again of parts, right? So what is a combination? First, you have got the nozzle, a rounded nozzle, which is mounted onto a housing, and it extends about an exit, create an opening, and the nozzle has an interior passage and a mouth. And the mouth, as you can see my cursor, right? The mouths have a aerodynamic surface, create a unique combination of diffuser, guide portion, and tapering portion. And this create a negative pressure here. So with the negative pressure, the law of inducement will pull in the air, and then the law of entrenchment will pull the air from the side. Yeah, so the air input will be enhanced. The volume of air will be increased 15 times, and you have a huge airflow. And that's the basic of the air multiplier technology. And what Dyson does is you apply the air multiplier technology in new application. In 2015, Dyson disrupted another industry, which is the beauty industry, with the supersonic hair dryer. This technology that they learned from the bladeless fan, they put it into a hair dryer. So what they do is they put a motor into the handle, and you have the annular airflow, and come up with an air dryer which is faster and more powerful and lighter, and also more easy to use. And supersonic air flyer became a global hit. And this is how this supersonic hair dryer are being protected by multiple patents. It's a portfolio of patents protecting this air supersonic hair dryer. And the one of the core patent is this patent filed in 2013. And what basically it protects again is a combination, right? It's a combination of feature where you have the main airflow, it has a main central ball or primary airflow, and you have another main airflow and the primary airflow generated by a motor. The primary motor will come out, and here you have this aerofoil design that create this low pressure, and it attracts the air through the law of inducement, and the air from the surrounding will get entrenched, and the bigger airflow will come out. And this heater is placed position here where the primary airflow will be heated before it goes out. This is how this combination works, and this again law of physics perfected and put into a device. And last but not the least, right, I would like to also talk about air wrap, another game changer in the hair care. So last time the hairstyler uses heat, and a lot of people's hair get burnt using the heat hairstyler. So what Dyson has done is using another law of physics, the Konda effect. The Konda effect uses the Konda effect to wrap around hair around the barrel, and it allows the user to curl or straighten the hair without damaging it. So this is again an application. The air wrap is an example of deep physics, applying deep physics into everyday life. And then you have this everyday users, and you protect it through strong pattern. So this is the Konda effect. It's the tendency of the air to curl, the fluid jet to curl around to attach to a curved surface, right? So what this phenomena of physics is being used into a hairstyler, using the principle to pull air by blowing the air and pull the air towards the barrel and wrap it around naturally. As a result, right, this become a product which is well loved worldwide, and it's all grounded in the physics law. And this is the combination of the air. This product, the hairstyling product, is protected through this patent, which was filed in 2021. And this is a combination again that forms this product. It has an airflow unit, it has a heating unit, it has a control unit that controls the different modes. Each mode has different heat and different flow rate, and when to transit between the mode. Right, this is how this hairstyling product is being protected. Okay, next, I would like to go on to the next part, which is industrial design. We want to address another equally important dimension of IP, which is the protection of aesthetic, right? We have discussed the utility patents that protects function. Now we turn to the design patents that protects the visual appearances or the shapes of the products, right? So Dyson protects the shape of its vacuum cleaner, protects the shape of its hair dryer, hairlines product, and also the fans with multiple industrial design. Industrial design is important because in retail environment, right, consumer makes purchasing decisions in seconds, and often driven by also the visual appearances, right? So a design protection, so you have a good function and you have a good design, you allow the Dysons to have the legal authorities to prevent competitors to produce products that looks similar, that have a similar overall impression. You can control the looks. You prevent competitor using different technology, but come up with something that looks similar and then confuse the market. So it protects the look and feel, and so that make sure that no competitors can try to copy the look and feel, right? Apart from the utility, you protect the look and feel. And these are some examples of the US design patent or industrial design filed by Dyson for the vacuum cleaner, for the fans, for the bladeless fans, some examples, and also for the air care products, right? So this is all the industrial design. And having secured the technology and also the design, right? The next challenge is the brand identity, right? So this is why trademark is important. So what happened in the Dyson's case is Dyson's adopt a brand sub-brand, main brand, house brand, and sub-brand strategy, right? So when a good product good enters the market and achieve great commercial success, what is inevitable is the competitor will try to capitalize on the product through association. They try to associate, right, the product with the counterfeit with the successful product. So what Dyson's did is respond is a comprehensive ecosystem of registered trademark. So at the foundation lies the house brand, which is Dyson. So Dyson's is the all-important corporate signature for the company. And Dyson's also protects the subsidiary brands, right? For the Supersonics, they protect Supersonics for the hair dryers, Arab for the hair styler, Ontrax for the audio headphones, Cyclones for vacuum cleaners, and they also have the cosmetic care products called Kitosan, right? This is all the sub-brands. So why this multiple brand sub-brand strategy? First is you create distinctive brand identity for each product category, right? So you can do target marketing for, like, for example, if you want to target hair styler, you just promote hair wrap, right? So you can do target marketing for very targeted customer recognition, and also by combining with the house brand Dyson, it prevents brand dilution. So while you promote hair wrap, you also promote Dyson at the same time. So brand dilution can be reduced. And Dyson also protects the trademark in multiple classes, right? For example, class 3 for cosmetics, 7 for machineries, 9 for the electronics. This comprehensive coverage is important so that no other third party can launch a product under under a similar, confusingly similar name in another category. So when you want to protect a trademark, right, you want to cover your key classes and also some of the related classes so that other people cannot come in and try register in other classes and to take away, to dilute your brand name. So this is what Dyson has adopted. So so with that, right, what I would say that, we have surveyed the portfolio of Dyson. We have studied the patent, the trademark, and the design. The question is, what is the commercial success outcome of the strategy? So the slide provide an answer. From a very initial single startup company, over the years, Dyson has evolved into a global enterprise and employing more than 8,500 workers across multiple jurisdictions, multiple continents. In 2023, the company reported annual revenue of 7.1 billion with a net profit of 1.4 billion. That is 20% profit margin. That's very high for an electronics product, and it's consistent. It's consistently sustainable profit margin. So this is more than a commercial success, right? They represent a tangible return on innovation, a consistent investment in innovation, and also in IP protection. And the profit margin, 20% profit margin, reflects what we talked about earlier, the IP moat, right? You have something that protect a sustainable competitive advantage that allows the company to generate above average return through the IP protection. So with that, I think I come to the end of my presentation.